The stars have always been silent watchers, flickering beacons that remind humanity of how small it truly is. Yet sometimes, from the unbroken stillness of the cosmic ocean, a messenger arrives. Something not born of our system, not belonging to our sun, not tethered by the ancient pull of planetary gravity. Something that has traveled longer and farther than human history can comprehend, drifting for eons in the abyss between stars. That is what 3I Atlas represents. A shard of another realm, a stranger slipping quietly across the threshold of our solar system. Astronomers first caught its glimmer as a faint, wavering signal, no larger than a whisper in the infinite static of night, and yet it carried with it a weight beyond measure. This was not a comet that had circled our sun 1,000 times. It was not an asteroid born of shattered rock within the familiar belt between Mars and Jupiter. Its path, its speed, its defiance of orbital tradition all proclaimed a truth, both exhilarating and humbling. It came from elsewhere, from outside, from beyond. Imagine an object moving so fast. Its trajectory never bends enough to be captured by the sunday. Instead, it carves a hyperbolic scar through the solar system, its arc shaped not by belonging, but by transience. It is a visitor, not a resident. It enters, passes, and leaves, carrying its secrets home to the unknown. Such is the essence of 3I Atlas, the third confirmed interstellar traveler known to humankind. And with its arrival, the cosmos once again reminds us that the universe is not a closed circle, but a boundless theater where even the smallest fragments can carry the weight of galaxies. The first sighting stirred the same primal awe as a comet glimpsed by ancient eyes. For early humans, such apparitions were omens, fire-haired messengers of gods or harbingers of disaster. Today, armed with equations, detectors, and orbital models, our gaze remains no less shaken. The emotions are different but equally powerful. Not dread, but wonder. Not prophecy, but mystery. For what, exactly, does this object carry? Dust from alien suns? Water from worlds unimagined? Or merely silence, a fragment that reveals nothing but its passing presence? In the black canvas of space, Atlas glides like an echo that refuses to vanish. It is not here for us, and yet it has entered our story. It is the pebble washed ashore by an ocean too vast to see, the relic of a place too far to know. Its very existence tells us that we are not alone in matter, that the galaxy trades its pieces freely, scattering seeds of rock and ice across the stars. And so, humanity watches. Telescopes turn their glass eyes, computers spin their models, and scientists whisper questions that can only be answered by shadows and reflections. What is it? Where has it been? What secrets does it hold in its silent, frozen heart? For a fleeting moment, the universe has granted us a messenger. 3I Atlas, a traveler from the void. Something massive may yet be revealed, but only if we listen before it is gone forever. When light first touched the polished lenses of human invention, the sky began to reveal its hidden language. For centuries, the eye alone had strained upward, unable to pierce the veil of darkness except through myth and imagination. But with the arrival of telescopes, Galileo's crude tube of glass in 1609, Herschel's grand mirrors reaching into the void, the universe became an observable stage. Each refinement of optics, each widening of aperture, carried with it the promise that one day humanity would see further, fainter, and more fleeting things. It was within this lineage of unblinking eyes that 3I Atlas was found. The discovery came not from a single night's glance, but from a vigilant network of instruments scanning the heavens. Among them, the Pan-STARRS Observatory in Hawaii and the ATLAS Asteroid Terrestrial Impact Last Alert System survey played pivotal roles. Designed not to seek beauty, but to warn Atlas's mission was to identify near-Earth objects, those hidden assassins of rock and ice that might one day collide with our fragile world. Ironically, in its hunt for threats, it became the sentinel that spotted a visitor, a glimmer faint and wavering, cutting across the background of fixed stars at speeds no ordinary comet should claim. The first humans to notice it did not in that moment know its full story. The light curve and path suggested an interloper, but confirmation required patience, data, and countless recalculations. Telescopes across the globe turned their domes in unison, measuring its arc night after night, refining the mathematics of its motion. Each observation tightened the certainty. This was not bound to the Sunday. This was not ours. It was interstellar. The echo of discovery resonates through time. Think of Edmund Halley in 1705, who realized that the bright apparitions seen in 1531, 1607, and 1682 were not three comets, but one, an object returning in cycles, obedient to Newton's laws. Halley proved that comets were not divine messengers, but celestial travelers governed by gravity. Centuries later, Pan-STARRS and ATLAS extended that revelation. Some travelers are not cyclical at all. They come once, from unfathomable distances, and then they vanish, leaving no second act. Such discoveries are rarely accidents. They are the fruit of decades of human persistence, of networks of observatories sharing data across oceans, of algorithms sifting through millions of points of light to notice one that moves differently. For 3I Atlas, the faint whisper of photons captured on a sensor in Hawaii became a spark that leapt across continents. Emails exchanged, coordinates confirmed, telescopes in Chile, Spain, and Arizona all joining in the chase. It was a race against time, for the visitor would soon grow fainter, retreating into the void from which it came. In those early days, before details sharpened, the excitement was palpable. Astronomers remembered 2017, when the first confirmed interstellar object, Oumuamua, startled the world with its impossible shape and inexplicable acceleration. They recalled 2019, when Borisov, the second visitor, revealed itself as a comet, carrying the frozen chemistry of another star system. Now, in 2024, a third had come, and like the first two, it would rewrite the story of what the solar system is and is not. What makes such a discovery profound is not simply its rarity, but its symbolism. To find one interstellar body is to encounter a miracle. To find three in less than a decade is to uncover a pattern that reshapes the galaxy in human minds. Telescopes are no longer only tools of curiosity, they are instruments of encounter. They are bridges by which fragments of alien realms step into our awareness. Behind the discovery are not just machines, but the people who operate them. Teams of astronomers working late into the night, calibrating exposures, correcting noise, cross-referencing orbital mechanics against catalogued stars. These quiet figures, often unnamed, are the custodians of wonder. They are heirs to Galileo's first turn of glass toward Jupiter's moons, to Caroline Herschel's comet-hunting sweeps of the sky, to Edwin Hubble's realization that the universe itself was expanding. Now, they carry the torch further watchers who caught sight of something not of our Sunday. Thus, the story begins not in the interstellar void, but in the very human act of discovery, an array of metal, glass, and silicon pointed skyward, sifting order from chaos, seeing the faintest of trails against the infinite darkness. In that light, fleeting but undeniable, the first chapter of 3I Atlas was written. For as long as humans have traced the heavens, the idea of visitors from beyond has haunted myth and science alike. But only in the 21st century did that ancient suspicion find confirmation in the cold clarity of orbital mechanics. In 2017, a thin shard of mystery, later named Oumuamua, swept through the solar system, moving too swiftly to belong. In 2019, Borisov followed, unmistakably a comet, carrying the frozen breath of another star. And then, in 2024, came the third, 3I Atlas, an emissary, carrying with it a lineage of astonishment. The designation 3I tells its story plainly, the third interstellar object ever recorded, where the first brought wonder and controversy, and the second offered chemistry from foreign origins. The third confirms what was once unthinkable, that the cosmos does not merely send light and radiation across gulfs of space. It sends material fragments, wanderers, bodies of ice and stone, into our neighborhood. The universe is not sealed. It leaks its secrets into our domain. Oumuamua had left astronomers bewildered. Its brightness flickered in ways suggesting an elongated or flattened shape, unlike anything bound within our solar system. Its acceleration, unexplainable by simple gravity, raised whispers of forces unknown outgassing too faint to see, or perhaps something stranger still. Borisov, in contrast, reassured. Its streaming tail, its volatile release, were textbook cometary behaviors, only with exotic chemical ratios hinting at alien birth. Atlas, then, entered into this narrative with heavy weight. It was not merely another interstellar passerby. It was evidence that such encounters may be more common than once thought, that our solar system is a crossroads through which countless exiles pass. Each one a fragment of a different birthplace, each one a messenger whose message may vanish before it can be deciphered. Its trajectory told the tale first. Hyperbolic in form, the orbit revealed itself as unbound, its eccentricity greater than 1, its speed beyond the escape velocity of the sun's dominion. It was as though the object had dipped its hand briefly into the firelight of our star, only to continue on its eternal path, indifferent to whether we noticed or not. The mathematics made no room for ambiguity. This was not a long-period comet returning from the Oort cloud, nor a stray asteroid tugged inward by gravitational accident. It was interstellar, by definition and by destiny. In naming it, astronomers turned once again to the instruments of its discovery. Atlas, the survey designed to detect killers of worlds, had instead caught a whisper of a traveler. The irony was striking. A telescope built to safeguard humanity from threats had instead given it a gift, a glimpse into the grand exchange of matter between the stars. But beyond the scientific precision lies something more human, the sense of a sequence, a pattern unfolding. The first was dismissed by some as a fluke, the second cemented reality. The third begins to suggest inevitability. Perhaps the galaxy is thick with such wanderers, each star system casting off debris across aeons, filling interstellar space with invisible highways of fragments. 3I Atlas, in that sense, is not just the third, it is a herald of countless others still unseen. And with it comes the weight of questions. Where was it born? Around what star did it once circle before some catastrophic event hurled it into exile? Did it witness the collapse of planets or the early turbulence of a forming system? How many billions of years has it wandered in silence before brushing against the thin shell of our sun's influence? Each of these questions lingers because Atlas is more than designation. It is confirmation. It is the third testament to the reality of cosmic drift, the scattering of matter across unimaginable distances. And with 3 comes certainty. The universe is not a set of isolated islands. It is a sea, and within it, debris drifts endlessly, sometimes washing ashore at our feet, sometimes passing us by, leaving us only the ache of wonder at what we almost understood. The first whispers of 3I Atlas's existence told only half its story. Its brightness, its arc, its speed, they were hints, not answers. But one detail quickly became unshakable: its trajectory. For while most comets bow in loyal arcs to the sun, caught in ellipses that return them again and again, Atlas cut a path of defiance. Its orbit was hyperbolic, an open curve, not a closed one. That distinction alone marked it as a stranger. Orbital mechanics are precise, almost merciless. A body bound to the sun traces an ellipse. A body balanced at escape velocity moves along a parabola. But to exceed that, to curve in a hyperbola, is to declare allegiance to no star. 3. Atlas carried such a signature. It came in fast, too fast for capture, accelerating toward perihelion only to swing back out, indifferent to the sun's pull. Its eccentricity, measured by the delicate mathematics of celestial mechanics, was unmistakably greater than 1. That number, more than any name, confirmed its origin. But the orbit also carried anomalies. Its path suggested not merely a drift from interstellar emptiness, but a journey shaped by violent beginnings. Something had flung it outward from its native system, perhaps a close pass by a gas giant, perhaps a cataclysmic collision, perhaps the slow instability of a crowded planetary nursery. Whatever the cause, the trajectory whispered of chaos, an exile hurled outward, never to return. To astronomers, every curve drawn across the night is a clue. The strange angle of Atlas's approach revealed that it was not a child of the Oort cloud, the distant halo of icy debris that surrounds our own system like a forgotten shell. Nor did it share kinship with the Kuiper belt, the icy frontier beyond Neptune. Its inclination and velocity betrayed a foreign signature, incompatible with anything the solar system could produce. As its arc was plotted, comparisons to earlier visitors became inevitable. Oumuamua, the first, had also carried a trajectory too swift to be bound. Yet its path was smooth, almost unnervingly so, leaving questions about how long it had drifted unperturbed. Borisov's trajectory, by contrast, resembled the familiar orbits of comets, except that its speed placed it forever beyond return. Atlas's curve was its own story, neither calm nor familiar, but sharp, almost jagged in implication. It had wandered long, and perhaps through violent domains. There is poetry in the notion of trajectory, a line traced across the void, bending briefly near our sun, then disappearing again into eternity, a glimpse of motion that humanity can measure but not follow. To study such a path is to study inevitability, the mathematics of exile, the geometry of loss. It is as though the cosmos permits us only a brush of contact, a reminder that not all things belong to our star. And so the astronomers recorded it. Numbers, vectors, angles, velocities, cold figures that, together, spell out something strangely human. For in tracing Atlas's path, they were tracing a story, the story of an object born elsewhere, abandoned by its home, and condemned to wander between suns. What makes the trajectory so haunting is not merely its hyperbolic nature, but what it represents. Each interstellar object is a survivor of ancient violence, a fragment torn from another world. To map its orbit is to read the scar of that violence, to glimpse a history billions of years older than Earth itself. Atlas's strange path is therefore not just an astronomical curiosity. It is a message, written in the language of celestial mechanics, that the galaxy is restless, its systems constantly birthing, colliding, and exiling. For humanity, to watch such a trajectory unfold is to confront both wonder and helplessness. The line of 3I Atlas cuts across our solar system once and once only. We can predict it, we can model it, but we cannot halt it. Its strange, unbound orbit is a reminder that not all mysteries come to stay. Some only pass through, leaving behind the ache of unanswered questions and the haunting curve of their escape. Brightness is a language the universe speaks in whispers. Stars shine with steady light, pulsars blink with clockwork rhythm, comets flare as their frozen skins crumble under solar heat. But 3i Atlas did not shine in predictable ways. Its brightness wavered, sometimes more luminous, sometimes diminished, as if cloaked in veils of shadow. The oscillations were faint, yet persistent enough to stir questions that ordinary explanations could not easily satisfy. To an astronomer, brightness is more than beauty. It is data, a measure of size, reflectivity, rotation, and composition. Each fluctuation carries meaning, the hidden pulse of a body revealed across incomprehensible distances. With Atlas, the light curve was puzzling. It suggested irregularity, perhaps, a body tumbling chaotically, exposing first one face, then another, to the distant Sunday. Or perhaps fragments trailed behind it, dust and ice scattering light unevenly, creating the illusion of flickering. But whatever the cause, its brightness refused to settle into predictability. This uncertainty drew uneasy parallels with its predecessor, Oumuamua, whose brightness had flickered in patterns that suggested a long, flat, or needle-like shape, something unseen before among comets or asteroids. With Atlas, the irregular glow raised the spectre of another anomalous geometry. Was it a fractured shard, broken by some ancient collision? Was it wrapped in a shroud of ultrafine dust, thinner than smoke, scattering sunlight in deceptive ways? Or was its surface reflective in patches, alternating between dull shadow and crystalline gleam? Brightness, however, is also ephemeral. Unlike mass or trajectory, it is sensitive to angles, to surface composition, to phenomena invisible to our instruments. A passing cloud of debris can alter it. Sublimating gases, releasing unevenly, can brighten one moment and dim the next. For Atlas, the variations hinted at activity, but not the kind that comets within our system display. Its eruptions, if they existed, seemed muted, inconsistent, like a voice speaking from beneath layers of silence. The mystery deepened as comparisons mounted. Borisov, the second interstellar traveler, had revealed itself with the unmistakable tail of a comet, shining brightly as ices vaporized in solar heat. Atlas, by contrast, showed no such theatrical plume. Its brightness wavered, but without a grand display. It was a comet that seemed reluctant to perform, a body that neither conformed to Borisov's exuberance nor to Oumuamua's austere silence. It dwelled somewhere between, a whisper where astronomers longed for clarity. To observers, the irregular brightness was more than a technical puzzle. It was a metaphor for the unknown. Each rise and fall was a reminder that this visitor did not belong to our categories. It was neither purely comet nor purely asteroid, neither passive rock nor flamboyant vapor. It was something in between, something hybrid, something other. In its refusal to reveal itself, it became all the more haunting. Consider the philosophical weight of this. A point of light, so faint that even the largest telescopes strained to hold it, carried within its fluctuations the fingerprints of another star system. A single photon striking a detector may have bounced from minerals forged in the heart of a foreign sun, or from ices frozen in a nebula humanity will never see. To watch its brightness shift is to watch the echo of alien creation, billions of years distilled into a flicker. And yet, the light deceives. Astronomers must wrestle with the possibility that the brightness holds no profound secret, that it is nothing more than geometry and rotation, an accident of orientation rather than essence. The universe is not obligated to be symbolic, but the human mind, yearning for meaning, cannot help but interpret. Thus, the irregular glow of 3i Atlas became not only a technical anomaly, but a mirror for human imagination. Some saw fragments scattering like lost memories. Some envisioned crystalline surfaces glittering against the void. Others, more cautious, whispered of dust and noise, of data too faint to trust. But all agreed on one truth. The brightness was strange, and in that strangeness lay the echo of a mystery still unfolding. From the beginning of modern astronomy, the universe has presented itself as orderly. Newton's laws describe the fall of apples and the dance of planets with equal elegance. Einstein deepened the stage, weaving time and space into a single fabric curved by gravity. For centuries, the cosmos seemed a clockwork mechanism, vast but comprehensible. Then, interstellar objects arrived, and with them came disruption. They are small in size, but immense in consequence, because each one seems to whisper that the rules are less secure than we believed. The shock of such visitors lies not merely in their existence, but in what they reveal. Comets and asteroids in our solar system obey certain expectations. They circle the sun, they return in cycles, they show predictable behavior when warmed. 3I Atlas, like its predecessors, violates this pattern. Its hyperbolic orbit tells us it is not bound. Its brightness fluctuations do not conform to cometary rhythm. Its very presence in our skies is a statistical improbability that shakes assumptions about how many such wanderers may pass unseen. To scientists steeped in precision, such defiance is unsettling. For decades, models of planetary formation assumed that the debris of creation mostly remains bound to its parent star. Ejections into interstellar space were thought rare, a cosmic afterthought. Yet here, within a single decade, humanity has encountered not one, but 3 interstellar exiles. Each encounter multiplies doubt. Are such objects far more numerous than anyone dared to imagine? Is interstellar space not empty, but thick with debris, countless fragments wandering in silence? Even more troubling are the deviations from familiar physics. Oumuamua's inexplicable acceleration was a wound to certainty. It did not outgas like a comet, yet it sped up as if pushed by invisible hands. Atlas, too, resists easy classification. Its behavior falls between categories, defying simple labels. The shock is not in any one anomaly, but in the accumulation, a growing sense that the neat order of celestial mechanics is haunted by shadows that will not fit. To feel this shock is to glimpse how scientists themselves wrestle with the unfamiliar. For the astronomer, the night sky is not poetry, but measurement, and yet here, even the language of numbers falters. Equations predict trajectories but cannot answer origins. Models of brightness falter when confronted with irregular flickers. The data insists something about these visitors is profoundly other. The emotional weight is hard to overstate. Imagine centuries of celestial study, generations of astronomers building an edifice of knowledge brick by brick, only to have a small fragment from elsewhere slip through and suggest that the foundation is incomplete. These are not grand collapses, but subtle fractures, hairline cracks in certainty. And in those cracks, wonder seeps through. Why should this be terrifying? Because if our solar system is not isolated, if matter is exchanged freely between stars, then the barriers between worlds are thinner than we believed. The very rocks beneath our feet may one day carry traces of other systems, and the reverse may already be true. The Earth itself may not be as singular as we imagine. Interstellar debris is a reminder of connectivity, but also of vulnerability. For if objects wander freely, then collisions are not merely local threats, but cosmic inevitabilities. And so, Atlas becomes more than a comet. It becomes a question mark carved across the firmament. A small body, faint and fleeting, daring humanity to confront its ignorance. The scientific shock lies not in its physical dimensions. It is no massive planet, no roaring black hole, but in its defiance. It forces us to admit that the universe may be filled with patterns we do not yet grasp. It is in this defiance that the beauty of science resides. For every shock, every anomaly, every disruption is an invitation. Atlas unsettles not to frighten, but to expand. It is a reminder that the cosmos is still wild, still beyond us, still vast enough to resist domestication by equations. In its strangeness lies the promise of deeper truths, truths that can only be revealed if we dare to follow the trail of mystery into the dark. If the universe is a great sea, then interstellar objects are driftwood upon its waves, fragments cast adrift from distant shores. 3I Atlas, faint though it is, carries within its icy heart the memory of another place. It is not a child of our sun, but of another star, born in a nursery humanity may never see. To follow its faint trail is to imagine a cosmic breadcrumb, a trace of the galaxy's grand dispersal. Astronomers, confronted with its unbound path, ask a simple yet profound question. Where did it come from? Its speed and trajectory, though precise, point not to a single origin, but to countless possibilities. Over billions of years, Atlas may have crossed regions where gravitational tides from stars and nebulae bent its journey again and again. By the time it reached us, the memory of its birthplace was erased, its coordinates scattered by chaos. Yet the object itself is a relic, a physical breadcrumb from that lost world. Theorists suggest such bodies are born in the violence of planetary formation. When a young star ignites and planets begin to coalesce, chaos reigns. Planetesimals collide, gas giants hurl fragments outward, unstable orbits lead to expulsions. Vast quantities of rock and ice are flung beyond the gravitational well of their parent star, condemned to wander forever. For every planet that survives, trillions of such fragments may be cast away. 3I Atlas is one of these exiles. It is sobering to think that our solar system, too, has likely contributed to this galactic diaspora. In its early youth, when Jupiter migrated inward and outward, its gravity scattered countless smaller bodies into oblivion. Some may still linger at the fringes of the Oort cloud, but many more may have escaped completely, now drifting invisibly through the galaxy. In that sense, Atlas is not just a visitor, it is kin, part of a vast exchange of matter across interstellar distances. Our system gives as well as receives. The metaphor of breadcrumbs becomes powerful here. Each interstellar object is a clue, a fragment of a larger story. A scientist examining its composition, its volatile gases, or its isotopic ratios, is like a tracker bending over a trail in the dark. A faint print in the soil tells not just of direction but of origin, of the nature of the traveler. Atlas may carry minerals forged in alien heat, or ices that condensed in conditions different from our sun's nursery. If studied closely, it could tell us how diverse planetary systems truly are. The difficulty lies in scarcity. These breadcrumbs are rare and fleeting. They move fast, fade quickly, and can only be studied from a distance. To imagine what they might reveal is to imagine holding a fragment of another world, but with hands bound by distance. The very thing that makes Atlas profound its otherness is also what makes it inaccessible. Yet even this limitation carries philosophical weight. The galaxy is filled with countless systems we cannot reach. And yet, on occasion, pieces of them come to us. They are not invitations, but reminders. Reminders that we are part of a web far larger than we can see. 3I Atlas is not just a traveler, it is proof that no star exists in perfect isolation. Matter drifts. Histories intertwine. The universe shares itself in small, reluctant ways. So, humanity bends its instruments toward this breadcrumb, trying to read what little story it carries. The faint flicker of its brightness, the spectral fingerprints of its chemistry, the arc of its trajectory, each becomes a letter in a larger text, a cosmic script written across billions of years, whispered into our skies for only a moment. The realization is humbling. Every interstellar object is a message in a bottle, drifting through the ocean of the galaxy. Some pass us by unnoticed. Others, like Atlas, brush against our awareness long enough for us to glimpse their message. Whether we can read it or not, its presence tells us that the universe is not silent. It leaves trails. It leaves breadcrumbs. And for those who are willing to look closely, they may lead not back home, but outward into the mystery of where all worlds begin. Every exile has a story of departure. For 3I Atlas, its tale begins not in the quiet of interstellar drift, but in the violence of its birth. To be cast out of a star system is not a gentle fate. It is the aftermath of upheaval, of collisions on scales so immense they border on incomprehensible. To imagine the making of Atlas is to imagine a world's chaos, where order collapses and fragments are thrown into eternity. Planetary systems do not form in silence. Around young stars, disks of gas and dust swirl in turbulent motion. Tiny grains collide, fuse, and fracture. Gravity knits pebbles into boulders, boulders into planetesimals, and planetesimals into embryonic worlds. But not every fragment finds a home. Some are shattered by collisions, others destabilized by gravitational giants, others still cast out in the storms of stellar infancy. The process of creation is also a process of exile. Theorists suggest that bodies like Atlas are the discarded children of these cosmic tempests. A newborn gas giant, moving inwards, perturbs countless smaller objects. Some spiral into their star, consumed in fire. Some crash together, forming moons or asteroids. And some are thrown outward, accelerated beyond escape velocity, flung like stones from a sling into the endless dark. In this violence lies the origin of interstellar debris. Consider Jupiter, the colossus of our own solar system. Its migration in the early epochs likely ejected trillions of icy bodies. Each was once part of our Sun's circumstellar disk, orbiting in fragile balance. But as Jupiter moved, its immense gravity destabilized their orbits, scattering them like leaves in a storm. Some found refuge in the Oort cloud, bound weakly at the system's edge. Others were given no refuge at all. They were hurled outward, never to return. If we could follow them now, we might find fragments of Earth's siblings wandering in alien skies. Atlas, then, is a mirror of what our own system once endured. Its hyperbolic flight path speaks of some distant Jupiter-like giant, pulling at its orbit until escape was inevitable. Or perhaps of a cataclysm, planets colliding, fragments blasted outward in the fury of impact. Each possibility paints a picture of a system alive with motion, fierce and unstable, long before it settled into quiet stability. There is poetry in this violence. For every planet that survives, countless fragments are lost. Creation and destruction are intertwined, and exile is the price of order. 3I Atlas carries the memory of that price. Though it drifts in silence now, its very existence testifies to a time of thunder, when stars blazed young and planets fought for survival. But this exile is not meaningless. In drifting across the galaxy, such fragments seed the interstellar medium with material forged in alien forges. Some may collide with other systems, delivering water, carbon, or minerals to young worlds. In this way, the violence of ejection becomes the foundation of possibility. A body like Atlas may be both victim and carrier, shattered from its home yet bearing the ingredients of life across unimaginable gulfs. The thought is haunting. What if Earth itself was seeded by such wanderers? What if molecules crucial to biology came not only from our sun's cradle, but from exiles cast adrift long before Earth was born. In studying Atlas, humanity is not merely examining an object, it is glimpsing the universal cycle of creation, destruction, and transmission, a cycle that binds worlds together through loss. And so, when astronomers trace Atlas's trajectory, they are not only mapping its path, they are reading the shadow of its violent birth. They see, written in its hyperbolic escape, the hand of a giant planet or the echo of a planetary collision. They see exile, they see survival, they see the violence that forges the architecture of stars. In the end, Atlas is more than a traveler. It is a survivor of catastrophe, a silent witness to the raw power of cosmic genesis, a shard of another world, carrying within its frozen core the memory of violence, and in that memory, the possibility of understanding how all worlds, even our own, first began. Discovery is always a race against time. When an interstellar object like 3I Atlas is first detected, astronomers know they have only a brief window before the visitor fades beyond the reach of their instruments. The sky does not hold still. Night by night, Atlas drifted further, its faint glow weakening as it moved away from the Sunday. Every hour mattered. Telescopes scrambled to lock onto its position, to gather what fragments of light they could, before the object slipped back into the invisible sea. The difficulty lies in distance and scale. Even at its brightest, Atlas was only a ghost, an icy shard reflecting the faintest traces of sunlight across unimaginable kilometers. To capture its spectrum, to measure its brightness with precision, required the most sensitive instruments on Earth. Large telescopes in Hawaii, Chile, Spain, and Arizona coordinated observations, trading data across continents. The community of astronomers worked as one, united by the urgency of a fleeting guest. But despite their efforts, the data came thin. The atmosphere above Earth blurred faint light, cosmic rays spattered noise across detectors, and the object itself refused to perform with the brightness of an ordinary comet. Astronomers found themselves chasing shadows, their instruments straining to hold on to something vanishing into the black. The frustration was palpable. What secrets might be locked within its frozen chemistry? What histories in its isotopes yet too faint, too far, too fast to reveal themselves? There is an irony here. The telescopes that discovered Atlas itself, and Pan-stars are built to find objects that might kill us. Their purpose is defense, to warn of asteroids on collision courses with Earth. Yet when faced with a harmless visitor from another star, their warning system became a window into wonder. A tool of protection became a tool of revelation. The dilemma for astronomers was not only technical but philosophical. How much of the unknown can be captured in a handful of data points? With each passing night, Atlas's brightness dropped until only the largest mirrors could glimpse it at all. Soon, it would vanish, leaving only orbital plots and spectral hints. Unlike comets of our own system, it would not return. There would be no second chance. Some likened it to watching a candle extinguish in a vast, cold cathedral. For months, astronomers pored over numbers, light curves, spectral lines, orbital models searching for coherence. And yet, the picture refused to resolve. Was Atlas a comet with muted activity? A fragment of rock covered in reflective frost? A hybrid of categories not yet defined? Each dataset deepened the ambiguity. This is the astronomer's paradox. The universe reveals itself only in fragments, in data so faint it borders on absence. To reconstruct truth from such scarcity is an act of both science and faith. They know the photons they measure have traveled from another star's creation through millions of years of interstellar drift, only to arrive as whispers on their sensors. And yet, with these whispers, they attempt to write the story of an entire world. The human dimension cannot be ignored. Behind every measurement is the image of a researcher, bent over a monitor in the dead of night, aligning telescopes, correcting errors, comparing notes with colleagues across oceans. They are custodians of wonder, chasing a fragment of alien matter across the sky, knowing full well that in a few weeks it will be gone forever. For them, the fleeting nature of Atlas is both a burden and a gift. It is a reminder that the universe does not bend to human schedules, that discovery is often a matter of timing and chance. It is also a reminder that every fragment of data matters, because once the visitor vanishes, those fragments are all that will remain. And so, the astronomers persevered. They captured what they could: light curves distorted by irregular brightness, spectra marked by faint chemical hints, orbital paths traced with exquisite precision, imperfect, incomplete, but invaluable. For in the fleeting presence of 3I Atlas lies the essence of astronomy itself, not certainty, but pursuit, not possession, but glimpse, not permanence, but the fragile beauty of a mystery slipping away. Light is more than illumination, it is revelation. When astronomers aim their instruments at an interstellar visitor, they are not simply measuring its glow, they are breaking it apart, scattering its photons into spectra, searching for the fingerprints of chemistry imprinted in faint bands of color. For 3I Atlas, those first spectral signatures carried whispers of something strange. Ordinary comets in our solar system reveal themselves through familiar lines: water vapor, carbon monoxide, methane, cyanogen molecules sublimating from their frozen cores when warmed by the sunday. These lines are like a universal song, recognizable across every icy body we have studied. But Atlas sang more quietly, and its notes did not align perfectly with the familiar score. Its faint spectrum suggested chemical traces that felt alien, as though the recipe of its birth had been written in a language our system seldom speaks. The difficulty lay in faintness. Atlas was small, dim, and quick to fade. Its signals hovered at the edge of detection, easily blurred by Earth's atmosphere or overwhelmed by cosmic interference. Yet even in that uncertainty, anomalies stood out. Some elements appeared in unusual ratios, others seemed absent altogether. The absence was as striking as the presence. What kind of system, what kind of star could give rise to such a composition? Theories quickly unfurled. Perhaps Atlas was born in a cooler nursery, orbiting a red dwarf star where temperatures froze exotic ices unknown to us. Or perhaps it formed near a hotter, more massive star where radiation forged its materials differently, leaving chemical scars that now linger in its core. Each possibility painted an image of a world beyond our sun, alien yet real, its evidence captured in a handful of spectral lines. Comparisons deepened the mystery. Borisov, the second interstellar traveler, had displayed chemistry surprisingly similar to our own comets: icy, volatile, familiar. Oumuamua, by contrast, had shown no clear outgassing at all, its silence suggesting a surface hardened by time or something stranger still. Atlas seemed to straddle the boundary, hinting at volatiles, but not with the clarity expected. It was as though it hovered between categories, neither fully comet nor fully rock, carrying an ambiguity that made classification impossible. This ambiguity matters because chemistry is history. The molecules locked within an interstellar object are fossils of its birthplace. To find water is to glimpse the cradle of oceans. To find carbon is to hint at the seeds of life. To find unusual ratios is to suggest environments unlike anything Earth has ever known. Atlas, in its faint and partial signals, suggested such an environment. Not entirely alien, but not entirely familiar. Philosophically, the implications ripple outward. Every interstellar fragment we detect is a messenger from another star system, carrying not speculation but substance, real atoms, real molecules, forged in another sun's light. When those atoms arrive in our telescopes, we are in direct contact with the chemistry of distant worlds. It is the closest we may ever come to touching them. Yet there is also humility in the encounter. The signals are faint, incomplete. Scientists cannot yet declare, with certainty, what Atlas is made of. The data is a whisper, not a shout. But even whispers can shift the imagination. They remind us that the universe is chemically diverse, that our solar system is not a template, but one variation among countless others. And so, the faint chemical signatures of 3I Atlas become more than data points. They become clues in a cosmic puzzle, fragments of a recipe written in alien dust. They invite speculation, they defy categorization, they remind us that the universe is richer and stranger than our limited samples have revealed. For astronomers, to see those spectral lines appear on a screen was to feel the weight of distance collapse. A fragment of another system, drifting for eons, now revealed part of its identity in a flicker of light. It was not a full story, not even a full sentence. It was a single word, spoken across the gulf of stars. But in that word lay the promise of chapters still unread. When a third traveler arrives, memory inevitably turns to the first 2, 3. I Atlas is not an isolated enigma. It is part of a sequence, a trilogy of arrivals that has unfolded in less than a decade. To understand Atlas, astronomers cannot help but set it against the shadows of its predecessors, 1I Oumuamua and 2I Borisov. Each one left behind a different kind of astonishment, and together they form a mirror against which Atlas's strangeness is measured. Oumuamua was the beginning of wonder and confusion. Discovered in 2017 by Pan-STARRS, it appeared as nothing more than a faint speck of light racing through the solar system on a hyperbolic arc. But its light curve betrayed something extraordinary. As it tumbled, it brightened and dimmed in ways that suggested an unprecedented shape, long and thin, perhaps cigar-like, or wide and flat, like a cosmic shard. Its acceleration, too, confounded explanation. It moved in ways gravity alone could not justify, as though propelled by something unseen. Outgassing seemed the obvious cause, but none was detected. This paradox left Oumuamua suspended in ambiguity, half comet, half asteroid, wholly inexplicable. Then, in 2019, Borisov arrived. Unlike its predecessor, Borisov revealed itself as unmistakably cometary. A long tail, a halo of sublimating ices, chemistry that echoed the comets of our own solar system. Yet within that familiarity lay subtle differences. The ratios of carbon monoxide to water, the abundance of certain volatiles, suggested an origin in a colder, harsher environment than our own. Borisov reassured by being recognizable, but it also hinted that planetary systems across the galaxy write their own chemical scripts. It was alien, yet legible. Into this narrative stepped Atlas. Where Oumuamua was too strange and Borisov was too familiar, Atlas appeared to dwell in between. Its trajectory confirmed its interstellar nature, but its physical behavior blurred boundaries. Its brightness wavered without displaying a clear cometary tail. Its spectral hints suggested volatiles, but faintly, and with ratios that did not fit neatly into known categories. It was not as silent as Oumuamua, not as flamboyant as Borisov, but something quieter, subtler, stranger. This triad of travelers tells us something profound. The galaxy is not homogeneous. Objects born of different stars will not resemble each other any more than every riverstone resembles another. Some will be jagged, some smooth, some shimmering, some dull. Oumuamua, Borisov, and Atlas are the first pieces of evidence that the galaxy's diversity of debris is as rich as the diversity of stars themselves. For astronomers, the comparison is both exhilarating and frustrating. Each object seemed to arrive with perfect timing, just long enough to reveal anomalies, just brief enough to vanish before answers could be secured. Together, they form a pattern, a sequence that suggests a universe far more dynamic than once believed. But they also leave questions hanging. Why did Oumuamua accelerate so mysteriously? Why did Borisov's chemistry carry such unusual ratios? Why does Atlas flicker without a tail? The human imagination fills in the gaps. Some see Oumuamua as a relic sail, a fragment of alien technology drifting abandoned. Others see Borisov as a reassuring sign that comets are universal, the building blocks of planets scattered everywhere. Atlas becomes, in this context, the enigmatic middle voice, less flamboyant than speculation, more elusive than reassurance. In this sequence lies a strange kind of comfort. The first interstellar object shocked us into awareness. The second proved that the first was not a fluke. The third whispers that such encounters may be natural, inevitable, a recurring part of cosmic life. And if three have arrived in less than a decade, how many countless others may have passed unseen, flickering through our skies before telescopes were sharp enough to notice? Thus, Atlas is not merely itself. It is the latest in a story that is only beginning to unfold. A reminder that the galaxy does not only send us light, but material fragments, silent messengers that confirm our place in a restless, ever-exchanging universe. Shape is destiny in the cosmos. A sphere tells of equilibrium, gravity pulling evenly from all directions. A jagged shard speaks of violence, a fracture born of collision. A spinning fragment carries the memory of impacts that set it tumbling. With interstellar visitors, shape becomes more than geometry. It becomes a clue to their story. And with 3I Atlas, that story is wrapped in shadow, its form elusive, inferred only from the way its light flickers as it drifts past. Astronomers know that an object's brightness is never constant if its shape is irregular. As it rotates, different facets reflect light, causing rises and falls in its observed curve. For Atlas, the pattern was uneven, inconsistent, as though the body were not simple or smooth, but broken, perhaps even fragmented into multiple pieces trailing in loose formation. Some speculated it might already be a shattered relic, a collection of smaller bodies bound only loosely, scattering dust so fine that even the most powerful instruments could barely trace it. This speculation echoes the memory of its predecessors. Oumuamua's shape remains one of the greatest puzzles of modern astronomy. Whether cigar-like, pancake-flat, or something altogether stranger, it defied every familiar category. Its tumbling motion suggested chaos, as though it had been tossed from its home by a violent hand. Borisov, on the other hand, showed the classic cometary form, its nucleus hidden within a cloud of vapor and dust. But Atlas once again refuses to conform. It hints at a structure that is neither stable sphere nor traditional nucleus, something fractured, irregular, difficult to pin down. The question of shape also raises deeper mysteries. If Atlas is elongated or broken, what forces sculpted it? Was it torn apart by a planetary collision? Chipped off a larger body in a grazing encounter with a gas giant? Or has it simply endured so long in interstellar drift that micrometeorite impacts and cosmic radiation have eroded it into something strange and unclassifiable? Each possibility is a different story of violence, survival, and time. Instruments struggled to provide clarity. The brightness curve was faint and noisy, too close to the edge of detection. Attempts to model its rotation left multiple solutions, some suggesting a long, thin body, others pointing to a cluster of fragments. Without a spacecraft to fly beside it, certainty would remain out of reach. And so, Atlas's shape joins the list of questions that will linger unanswered, a permanent enigma written into the record of the stars. But perhaps the deeper truth is not its precise form, but the implication of its irregularity. If Atlas is broken, then it is a survivor, a piece of a larger whole, reduced by violence, but not erased. Its fragments carry within them the memory of a world no longer visible, a planet or planetoid that once was, now gone. Its very irregularity is evidence of history, a physical scar of events lost to time. Philosophically, this realization carries weight. To imagine Atlas as a shattered relic is to confront the fragility of worlds. Even planets are not eternal. Systems collide, fragments scatter, and what remains drifts through eternity as witnesses of their own destruction. In its broken form, Atlas is not only an object, it is a memorial, a silent monument to a cosmic cataclysm. And yet, there is beauty in this fragility. Just as broken pottery can carry the story of an ancient civilization, so too can fragments of rock and ice carry the memory of alien systems. Even in ruin, Atlas is precious. Perhaps more so because in its scars lies a tale of survival, written not in words but in geometry, rotation, and flickering light. In the end, the question of shape may never be answered. The telescopes caught only glimpses, the data too faint for certainty. But the uncertainty itself is telling. It reminds us that the universe does not yield easily, that some mysteries remain half seen, half imagined. Atlas drifts away with its form unresolved, leaving behind only the haunting suggestion that it is something broken, something cloaked, something too complex to categorize. A body whose shape, like its story, resists being captured in full. There is a rhythm to the cosmos, a trust in the way its laws unfold. Gravity pulls, inertia carries, and bodies move according to predictable curves. From the paths of planets to the drift of comets, celestial mechanics have always been reliable companions to human understanding. But then, something happens that does not fit. With 3i Atlas, that dissonance emerges again. Faint anomalies in its motion, whispers of acceleration that do not conform to the pure dictates of Newton's gravity. Astronomers know this feeling. They felt it first with Oumuamua, when calculations showed that the interstellar shard was moving faster than gravity alone could explain. It should have slowed as it receded from the sun, but instead it seemed to carry an invisible push. The obvious explanation was outgassing jets of vaporized ice pushing the body forward as they streamed away. But no tail was seen, no plume, no vapor bright enough to justify the force. And so, the acceleration became an enigma, a scar across the certainty of physics. With Atlas, the suspicion rose again. Its brightness flickered, its path seemed to show hints of deviation subtle, hard to pin down, but provocative. Was it also accelerating in ways unaccounted for? Were unseen jets nudging it through the void? Or was there something else, something not yet named? Astronomers worked feverishly to refine their data, aware of how easily noise could masquerade as anomaly. Yet even the possibility was unsettling. For if interstellar bodies consistently display forces that resist explanation, the implications are profound. It would suggest that the physics we trust to govern celestial motion is incomplete. Not wrong, but insufficient. There may be variables we cannot yet see, exotic ices sublimating in undetectable ways, interactions with cosmic radiation, or forces we have not yet defined. Each anomaly is a reminder that the universe does not conform fully to our expectations. The shock is not in the scale of the object. Atlas is small, a fragment no larger than a modest mountain. The shock is in its defiance. A tiny body, crossing the solar system only once, has the power to challenge the very rules written by Newton and Einstein. That defiance carries a weight out of proportion to its size. It is a mosquito nudging the fabric of cosmic order, yet leaving ripples large enough to disturb the human imagination. And here lies the terror. If small things cannot be explained, how secure is our understanding of the larger ones? If a shard of ice and rock carries mysteries beyond physics, what of the black holes, the dark energy, the invisible scaffolding of the universe? Atlas becomes a reminder that certainty is fragile, that the order we think we have grasped may conceal depths still hidden. The echoes of this realization run deep. In the 19th century, the orbit of Mercury showed small deviations that Newtonian mechanics could not explain. The anomaly gnawed at physics until Einstein's general relativity revealed a deeper truth. Space and time themselves were curved. Could interstellar anomalies be today's Mercury small irregularities that hint at revolutions yet to come? Most scientists resist such leaps. The careful path is skepticism, caution, restraint. They remind themselves that faint data is treacherous, that instruments can deceive, that the simplest explanation must come first. And yet, the anomalies linger in memory, refusing to vanish. Atlas may not yet prove that physics falters, but it joins a pattern of unease, a chorus of faint voices that suggest the cosmos still has surprises in store. For the philosopher, this is where science becomes poetry. The irregular motion of a drifting fragment becomes a symbol of humility. It tells us that even in an age of colliders and satellites, the universe retains its secrets, that the rules we hold sacred are provisional, awaiting refinement, awaiting the next revelation. In this way, Atlas is more than a small body on a hyperbolic path. It is a reminder that certainty is temporary, that physics is not a finished book, but a draft still being written. Its anomalies, whether real or imagined, are warnings. Warnings that the cosmos cannot be tamed, that its laws still hold shadows beyond our grasp. And perhaps, in those shadows, lies the next great revolution of human thought. When nature hesitates to explain itself, imagination fills the silence. The anomalies of interstellar visitors, faint as they are, inevitably awaken the most provocative question of all. What if these objects are not merely natural? With 3i Atlas, as with Oumuamua before it, speculation turns toward the possibility of something engineered, something built, something sent. The leap is audacious, but the mind cannot resist. It began with Oumuamua. Its acceleration, its inexplicable shape, its silence in every wavelength but reflected sunlight, these were peculiar enough that even respected scientists allowed themselves to wonder. Could it be a light sail, a fragment of alien technology designed to ride starlight across gulfs of space? Harvard astronomer Avi Loeb famously voiced this possibility, igniting debate that lingers still. Most dismissed the idea, preferring natural explanations, but the seed was planted. The universe, after all, is vast, and if intelligence has arisen here, could it not have arisen elsewhere? Could interstellar visitors be the relics of civilizations long gone? Atlas carries less theatrical strangeness than Oumuamua, but still, its irregular brightness, its ambiguous chemistry, its unbound flight, all invite whispers of the extraordinary. What if its fragments are not the result of natural collisions, but the remnants of some constructed probe shattered by ages of drift? What if its silence is not the absence of outgassing, but the echo of an object no longer alive in function, but still carrying the bones of intention? These are speculations, not conclusions. Science, cautious by necessity, frames them only as possibilities, unlikely yet not impossible. But culturally, the resonance is powerful. Humanity longs for contact, for signs that it is not alone. A body crossing the solar system from another star is, by definition, alien. To wonder if it is also artificial is a natural extension of curiosity. The question of alien relics is not limited to idle fancy. Physicists and philosophers alike have considered that if civilizations rise and fall across the galaxy, their artifacts may endure longer than their makers. Probes, sails, and machines could drift for millions of years, carried by momentum across interstellar space. Some might even be deliberately released messages in a bottle, scattering seeds of technology across the void. If so, objects like Atlas may not only be messengers of geology, but of intelligence. Yet, skepticism remains. Extraordinary claims demand extraordinary evidence, and Atlas, faint and fragmentary, offers no such proof. Its irregular flickering can be explained by rotation. Its trajectory is the natural product of ejection. Its chemistry, however unusual, fits within the spectrum of possibility for star systems unlike our own. No hidden transmissions have been detected, no signatures of design revealed. For now, the balance of probability lies firmly with nature, not with intention. But here lies the deeper truth. Speculation itself has value. It expands the horizon of thought, reminding us that science is not only about what is likely, but also about what is possible. In contemplating alien hypotheses, humanity confronts its own place in the cosmos, its hopes, its fears, its longing for connection. Atlas becomes not only an object of study, but a canvas for imagination, painted with questions that transcend data. The silence of such bodies is perhaps the most haunting aspect. If they are natural, their muteness is expected. If they are artificial, their silence may be the echo of civilizations already gone. Either way, the absence of voices in the dark presses upon us, reminding us of our isolation. The galaxy may be filled with fragments, but fragments are not companions. And yet, every whisper of alien speculation reignites wonder. For Atlas, even without proof, embodies the possibility of contact, if not with the living, then with the relics of lives beyond. It is a reminder that the search for meaning in the stars is not only scientific, but profoundly human. In the end, perhaps Atlas is only rock and ice, a fragment hurled outward by blind forces. But to look at it and ask, what if that is the mark of a species still yearning, still listening, still waiting for the universe to answer? Silence can be louder than sound. In the case of 3I Atlas, the silence of certainty is perhaps its most unsettling quality. Astronomers pointed their instruments, gathered the light, charted the orbit, and yet answers remained out of reach. Every observation returned fragments of a story, but no conclusion. The visitor seemed to resist definition, leaving science suspended in an uncomfortable quiet. This is not the silence of ignorance alone. It is the silence of contradiction. When physics is applied to a comet, the equations close neatly, motion explained by gravity, brightness by outgassing, spectrum by common volatiles. When applied to Atlas, the equations tremble. Its trajectory is interstellar, but its activity is ambiguous. Its brightness flickers, but no clear tail is seen. Its spectrum suggests ices, but in unfamiliar proportions. It does not fit the categories we rely on. In its silence, it challenges us. Scientists often say that nature speaks in data, but Atlas speaks in refusals. It refuses to shine brightly enough for certainty. It refuses to reveal a tale when one is expected. It refuses to remain consistent in its light curve. Each refusal is a kind of silence, a withholding, and in that withholding lies a weight heavier than words. This silence is not unfamiliar in science. At the turn of the 20th century, the orbit of Mercury deviated subtly from Newton's predictions, a silence that persisted until Einstein's relativity gave it meaning. The night sky, too, once held the silence of galaxies, mistaken for nebulae, until Hubble revealed their true vastness. In each case, silence was not absence, but invitation. Atlas joins this lineage, a reminder that mystery often hides in quiet places, in faint lights, in anomalies too small to dismiss. For astronomers, the frustration is acute. Every photon gathered by telescopes feels like gold, precious and finite. To analyze Atlas is to work with scraps, tiny fluctuations, faint chemical hints, orbital data blurred by noise. It is like trying to reconstruct an epic from a handful of torn pages. They know that whatever truth lies within Atlas will remain incomplete, forever muted by the faintness of its voice. And yet, the silence carries a strange beauty. It mirrors the larger silence of the cosmos itself, the silence that surrounds Earth when radio signals fade into the void, the silence that SETI listens to year after year, hoping for a reply that never comes. Atlas, in its own way, embodies that cosmic quiet. It passes through our system without speaking, a wanderer who carries secrets but does not share them. Philosophically, this becomes a meditation on knowledge itself. Humanity desires clarity, yet the universe often grants only glimpses. The silence of Atlas is not cruelty, but reality. Some truths may always remain beyond reach, glimpsed but never grasped. To confront this is to confront our limits, and perhaps to accept them. Still, there is power in silence. It forces imagination to expand, to fill the void with hypotheses and speculation. It drives new questions, new instruments, new missions. In refusing to fit, Atlas compels us to stretch our categories, to admit that our taxonomies of comets and asteroids may be provincial, suited only to our own system. Out there, among the stars, the possibilities are wider, stranger, quieter. And so, 3i Atlas passes not as an answered question but as a riddle. Its silence is not the end of inquiry, but the beginning. It tells us that not every mystery will speak, that some will only brush against us, leaving a memory of unanswered wonder. In the gravity of that silence, humanity feels its own smallness, but also its persistence, the drive to listen harder, to build better eyes, to strain against the quiet until meaning emerges. In the end, the silence of Atlas is not empty. It is filled with potential. Like the pause between notes in music, it shapes the melody by absence. It reminds us that knowledge is not given freely. It must be sought, wrestled from shadows, teased from whispers, and sometimes it must be accepted as incomplete, a reminder that the universe is not ours to master, but ours to pursue. The story of 3i Atlas is not only the story of one fragment, but of a vast unseen multitude. If 3 interstellar visitors have been noticed within less than a decade, how many others pass through unseen? How many glide across the solar system without reflecting enough light to be caught by our telescopes? The unsettling answer, suggested by calculations and probability, is that perhaps trillions of such bodies roam the galaxy. They are the nomads of the Milky Way, worldless, starless, wandering forever between suns. Astronomers have long suspected such exiles. The processes that birth planetary systems, gravitational scattering, collisions, the migration of giants should produce far more outcasts than survivors. For every planet that stabilizes, countless planetesimals are cast away. Each system may contribute billions of objects to interstellar space. Multiply this by the hundreds of billions of stars in our galaxy, and the number of wandering bodies becomes unthinkable. Interstellar space, once imagined as empty, begins to look like a dark ocean strewn with invisible wreckage. These exiles are difficult to detect precisely because they are not bound. They do not return, do not linger near the warmth of stars. They are small, cold, and dim, their presence betrayed only when chance carries them briefly across our field of view. To glimpse one, as we did with Atlas, is to see only the tip of a vast iceberg hidden in the black. The realization changes perspective. For centuries, humans believed the solar system was an isolated island in an infinite void. But interstellar visitors reveal a different truth. The galaxy is porous, systems are not closed, matter migrates. Our solar system is part of a galactic exchange, constantly crossed by wanderers born of distant stars. The boundaries between us and them are blurred by these quiet crossings. This knowledge unsettles as much as it inspires. For if countless bodies drift unseen, some may one day collide with Earth or its neighbors. The likelihood may be low, but the consequences catastrophic. Yet danger is only one side of the truth. The other is possibility. Each interstellar body is a vessel of alien chemistry, carrying minerals and ices forged in environments unlike our own. They are samples of worlds we cannot visit, messengers of diversity scattered across the stars. Philosophically, the thought is breathtaking. If the galaxy is filled with nomads, then exile is not exception but norm. Our planets, bound and stable, are the rare survivors. The vast majority of matter may wander endlessly, bearing the memory of systems that have long since vanished. Atlas is one such memory, crossing our sky for a fleeting moment, then returning to the deep silence of galactic drift. Perhaps the greatest lesson of these exiles is humility. We think of Earth as a world defined by permanence, but permanence is fragile. Systems form, scatter, collapse. Planets endure for a time, but fragments may last longer. Atlas may outlive the system of its birth, outlive even our sun, drifting through eternity long after civilizations rise and fall. In that sense, exile is also immortality. And so, the presence of Atlas whispers of an unseen multitude, a hidden galaxy, not of stars but of fragments, trillions of bodies traveling alone, without home, without light. Some we will glimpse, most we will never know. But their existence tells us that the universe is restless, that matter is forever in motion, that creation and destruction are not opposites but parts of the same eternal drift. In Atlas, humanity sees not just one object, but a symbol of countless others, a single grain of sand that reveals the desert, a lone wanderer who speaks for a vast silent multitude, forever passing, forever unseen. To pursue the fleeting requires tools as relentless as the mystery itself. When 3I Atlas entered our awareness, astronomers turned to every available instrument, each telescope a different kind of eye, straining into the dark. The Pan-STARRS array in Hawaii, with its wide-field survey design, first swept the faint visitor into view. Atlas itself, the asteroid terrestrial impact last alert system, alerted the world. But these were only the opening moves. To study an interstellar body requires an orchestra of instruments, each tuned to a different frequency of truth. Optical telescopes, such as those in Hawaii and Chile, tracked Atlas's light curve, recording its subtle fluctuations. Through these eyes, astronomers measured brightness, rotation, and the fleeting signatures of shape. Spectrographs attached to giant mirrors split that light into rainbows, searching for the fingerprints of alien chemistry. Each faint absorption line, each spectral dip, was a clue to its frozen ingredients. The Hubble Space Telescope, orbiting high above Earth's atmosphere, was called upon to provide a sharper view. From its position in the void, free of atmospheric distortion, Hubble could catch details invisible to ground-based observatories. Its precision allowed astronomers to probe whether Atlas shed dust, whether it bore the faintest trace of a cometary coma, or whether it moved silently as a bare shard of rock and ice. Radio telescopes, too, were turned toward it, listening for echoes of radar beams or for natural radio emissions. Though none revealed extraordinary anomalies, the attempt itself spoke of humanity's hunger to capture every possible signal before the visitor was gone. Even instruments designed for planetary defense, such as NASA's planetary radar systems, sought to mark its passage, though Atlas, faint and fast, was a difficult target. Future instruments were imagined even as Atlas retreated. The Vera C. Rubin Observatory, nearing completion, promises to map the sky with unprecedented sensitivity, catching transient visitors with greater clarity. The James Webb Space Telescope, with its infrared vision, could one day peel away the cloak of coldness around such bodies, measuring heat and revealing compositions too subtle for visible light. In Atlas, astronomers saw not only a mystery, but a test case, a rehearsal for how humanity must respond when the next interstellar messenger arrives. And yet, the urgency was palpable. Unlike planets or moons, interstellar visitors offer no second chances. Once gone, they are lost forever. No spacecraft existed to pursue Atlas. Missions were imagined in white papers and conferences, probes that might launch on short notice to chase future visitors. But for Atlas itself, these dreams came too late. All that could be done was to observe from afar, capturing as much data as possible before the trail faded. Here lies the bittersweet paradox. The tools of pursuit are extraordinary, the result of centuries of human progress. Giant mirrors, orbiting observatories, radar systems, and computers capable of handling torrents of data, all marshaled to study a faint dot of light no larger than a mountain, drifting faster than any spacecraft humanity has ever launched. And yet, even with these tools, the mystery resists. The universe does not yield itself easily, not even to our most advanced instruments. Still, the effort itself is meaningful. Each telescope turned toward Atlas represents humanity's refusal to let the moment pass unnoticed. It is an act of defiance against cosmic indifference, a way of saying, we are here, we are watching, we are listening. In the pursuit of one fleeting visitor, humanity measures not only the object itself, but its own determination to understand. Philosophically, these tools of pursuit are more than machines. They are extensions of human senses, fragile bodies reaching outward across impossible distances. To point them at Atlas is to extend ourselves into the void, to declare that even the faintest whisper matters, that nothing passing through the solar system will be ignored. Atlas may not have revealed all its secrets, but the instruments turned upon it forged something lasting. They sharpened our readiness, they expanded our imagination, they set the stage for the next encounter. The pursuit of Atlas is, in the end, a rehearsal for eternity, the patient practice of a species determined to catch the messengers of the stars, however brief their passage, however faint their light. What Hubble strained to glimpse, the James Webb Space Telescope could, in theory, have unveiled in detail. If only the timing had been different, if only the orbits had aligned with possibility. For Atlas, fading swiftly into darkness, Webb's infrared eyes arrived too late. Yet astronomers could not help but imagine what might have been revealed had its mirrors been turned upon this wanderer. Unlike visible light telescopes, Webb's power lies in the unseen glow of heat. Even the coldest ices, drifting far from stars, emit faint infrared signatures. Where optical instruments see only silence, Webb can detect composition, temperature, and structure. Applied to a body like Atlas, such vision might have stripped away ambiguity. The spectrum of its ices would have been recorded with precision, the fingerprints of water, methane, carbon dioxide, or exotic compounds frozen in alien conditions. Ratios of these molecules could have revealed the nature of the star system from which it came, whether a cool red dwarf nursery or the violent furnace of a massive sunday. Infrared imaging might also have clarified its surface. Is it cloaked in dust, a veil scattering light unevenly? Or is it bare rock, its surface altered by eons of radiation? Such questions hover unanswered, because optical data alone cannot pierce the shroud of subtle chemistry. But Webb's detectors, tuned to wavelengths beyond human sight, could have traced even the faintest emission from sublimating gases, distinguishing between activity too weak for other telescopes to detect. Beyond chemistry lies form. If Atlas were fragmented, trailing multiple shards, infrared imaging could have separated them, resolving what optical telescopes blur. Its irregular brightness might have been explained not by tumbling alone, but by the presence of companions, fragments traveling together after a long-ago disruption. Webb's clarity could have revealed whether Atlas is singular or plural, intact or broken, whole or scattered. And then there is time. Infrared astronomy does not only answer what, but when. By reading the thermal inertia of a surface, the way it holds and releases heat, astronomers can estimate how long it has wandered in cold interstellar space. A fresh exile, ejected recently from its system, would bear a different thermal signature than an ancient wanderer, drifting for billions of years. In this way, Webb could have touched the chronology of Atlas, placing it within the vast timeline of galactic history. The thought is bittersweet. By the time Webb was fully operational, Atlas was already slipping beyond reach, too faint for even its golden mirrors to find. And so, what could have been a revelation became a missed encounter, a reminder of how fragile timing is in astronomy. The universe offers moments, and if we are not ready, they pass. Yet the dream persists. Webb, though it missed Atlas, will almost certainly meet its successors. As interstellar objects continue to arrive, it will be waiting, poised to reveal their secrets. The lessons of Atlas sharpen the urgency. When the next messenger crosses our sky, we must be ready to turn Webb's eyes toward it before it fades. Philosophically, Webb represents more than a tool. It is the extension of human longing, the desire to see the invisible, to grasp the faintest truths hidden in darkness. In imagining what it could have revealed about Atlas, we glimpse both our limitations and our potential. The universe offers fragments, and we build ever sharper instruments to hold onto them before they vanish. In the silence left by Atlas's departure, Webb becomes a symbol of hope. The next wanderer will not escape so easily. Its chemistry, its structure, its story may yet be written in the light of infrared. For now, Atlas leaves us only with speculation, but speculation shaped by the knowledge that our instruments are finally capable of listening more deeply than ever before. Every interstellar traveler carries within it a frozen library. The dust, rock, and ice of bodies like 3I Atlas are not inert matter, but archives of chemical processes that took place in alien nurseries of creation. When scientists examine the faint spectral lines from such an object, they are not just studying minerals, they are reading the chemistry of other stars. Atlas, in its silence and ambiguity, offered only fragments of that library. But even fragments can alter our understanding of the galaxy's grand alchemy. Comets in our own system are often called time capsules. Their cores preserve the raw ingredients of the early solar nebula ices unaltered since the Sun was young, carbon compounds that predate Earth itself. By studying them, we glimpse the conditions that once prevailed here in the dawn of planets. But interstellar comets are something more. They are time capsules from other systems, each carrying the imprint of a different stellar nursery. They are the chemistry of elsewhere, delivered by chance into our reach. The faint traces from Atlas suggested a mix that was neither wholly alien nor entirely familiar. Certain volatiles echoed our own comets, but in unusual proportions. Some expected molecules seemed muted, others hinted at abundance. This irregularity, though frustrating in its incompleteness, is what makes Atlas precious. It reminds us that planetary systems are not copies of one another. Each is a unique chemical experiment, shaped by the temperature, radiation, and history of its star. Consider the implications. If Atlas carried a higher abundance of carbon monoxide than Earth's comets, it may have formed in a colder environment, further from its star, where such volatile ices could survive. If it lacked certain hydrocarbons, perhaps its parent system was bathed in harsher radiation, stripping molecules that survive more easily around our sunday. Each difference is a clue, a fingerprint of conditions unseen. More provocatively, interstellar bodies may help answer one of science's oldest questions: is life inevitable wherever chemistry permits? The seeds of biology, amino acids, organic compounds, simple sugars have been found in comets of our own system. If similar molecules were detected in Atlas or future visitors, it would suggest that the raw ingredients of life are scattered freely through the galaxy. Life, then, may not be a miracle confined to Earth, but a natural flowering wherever conditions allow. Atlas's faint chemistry was not enough to confirm such dreams, but it sharpened the question. Each interstellar object adds weight to the possibility that panspermia, the transfer of life's building blocks across star systems, is not fantasy, but inevitability. Exiles like Atlas may be couriers, carrying not only dust but potential, scattering fragments of chemistry across the cosmos like dandelion seeds on the wind. But there is humility in this vision too, for even if such chemistry is abundant, it may not always find fertile ground. Most wanderers drift through the void untouched, their molecules never meeting a young world. Their richness is lost in silence, and yet the possibility remains. Some fragments do collide, do mingle, do sow. In that possibility lies hope that Earth's story may not be unique, that the galaxy itself may be fertile ground for life. Philosophically, this transforms Atlas from a rock into a question. What stories are written in the molecules it carries? Are they the simple minerals of lifeless stone, or the precursors of biology? Do they tell of a world with oceans, or of a frozen wasteland orbiting a dim star? Even if we cannot yet answer, the question itself is profound. For it reminds us that every fragment drifting between stars is a witness to creation, a participant in the endless cycle of matter becoming form, form becoming possibility. In the chemistry of Atlas, faint though it is, we glimpse the interconnectedness of all things. The atoms within it may once have burned in the heart of a distant sun, been woven into a planet, shattered in collision, and ejected into eternity. Now, those atoms reflect their light into our telescopes. They speak of alien forges, alien histories, alien possibilities. And though Atlas has passed, the chemistry it hinted at remains etched in memory, a reminder that the universe is not just a stage of stars and gravity, but a laboratory where every fragment, every exile, carries the recipe of worlds unknown. Probability is a quiet tyrant. It governs everything from the throw of dice to the formation of galaxies, and it insists that certain events should be impossibly rare. By that logic, the arrival of even one interstellar object within a human lifetime should have been remarkable. Yet in less than a decade, 3 such wanderers, Oumuamua, Borisov, and now 3, I-Atlas, have swept through our solar system. Each discovery widens the eyes of astronomers, for it defies the expectations of probability. Before 2017, when Oumuamua startled the world, models suggested that the density of interstellar objects was low. The galaxy was thought to contain them, yes, but scattered thinly, like occasional stones along an endless beach. Detecting one seemed like a rare fortune, an alignment of chance and vigilance. Then Borisov arrived, confirming the reality of a galactic population, and when Atlas followed so swiftly, the statistical mystery deepened. Had humanity's expectations been wrong all along? The numbers are unsettling. If 3 have appeared in such quick succession, The implication is that interstellar space may be far more crowded than once believed. Estimates now suggest that for every star, billions of such objects may wander. The Milky Way, then, is not an empty gulf punctuated by suns, but a drifting sea of fragments, trillions of icy and rocky exiles, most of them forever invisible. Why, then, have we seen them only now? The answer lies partly in technology. Wide-field survey telescopes like Pan-STARRS and Atlas, designed to guard Earth from incoming asteroids, have only recently gained the sensitivity to detect such faint, fast-moving bodies. For centuries, interstellar wanderers may have swept past unnoticed, their brief glimmers lost in the noise of the night. It is not that the visitors are new, but that our eyes are finally sharp enough to see them. Yet another possibility lingers at the edge of thought. Perhaps there truly is a clustering, a flurry of arrivals in this cosmic moment. Could there be patterns unseen, guiding multiple wanderers into our system within such a short time? Are we drifting through a denser stream of interstellar debris, the wake of a distant cataclysm? Perhaps a planetary system far away shattered, and its fragments now scatter across the galaxy, some of them finding their way here. Philosophically, this question reaches beyond statistics. If interstellar bodies are abundant, then the universe itself is dynamic in ways we had not imagined. Planetary systems are not closed containers but leaky vessels, constantly spilling material into the galactic sea. Each star contributes to this migration, creating a vast, unseen network of exchange. The galaxy becomes less like a collection of isolated islands and more like a living ocean, with currents of debris flowing endlessly between its shores. The mystery of probability unsettles because it shifts perspective. Where once interstellar space was emptiness, now it is crowded. Where once the arrival of a visitor was a miracle, now it may be routine. The rare becomes common, the improbable inevitable. And in that shift lies a quiet transformation of how humanity imagines its place in the galaxy. For if such objects are everywhere, then each one we detect is not an anomaly but a representative. Atlas is not unique but typical, a messenger of the ordinary chaos that governs all stars. To study it is to study the galaxy itself, distilled into a fragment that happened, by chance, to pass our way. This realization is both humbling and empowering. Humbling because it reveals how blind we were until recently, how much has passed us by unnoticed. Empowering because it suggests that the future will bring not one or two such discoveries, but hundreds, even thousands. Each one will sharpen the statistics. Each one will expand our understanding of the galactic population. And so, Atlas is part of a pattern larger than itself. Its presence raises a question that will echo for decades. Was its arrival coincidence, or was it part of something massive, a hidden structure of probability woven through the galaxy? In its faint arc, we glimpse not just one object, but the hint of a cosmic tide, a flow of exiles whose numbers and origins remain a mystery as vast as the stars themselves. When probability falters, imagination searches for deeper order. The appearance of 3 interstellar visitors in quick succession seems improbable if they are scattered randomly across the galaxy. Some astronomers began to ask whether unseen forces might be guiding them, drawing them along hidden paths. In this vision, 3I Atlas is not merely a solitary wanderer, but part of a larger procession drifting along invisible rivers of gravity that thread through the Milky Way. Gravity is the sculptor of structure. It pulls galaxies into spirals, clusters stars into arms, and weaves dark matter into cosmic webs. Within our own solar system, it is gravity that creates the resonances of Jupiter's moons, the shepherding of Saturn's rings, the migrations of comets from the Oort cloud. If such patterns exist locally, why not on larger scales? Perhaps the galaxy is not a random scattering of debris, but a landscape shaped by gravitational currents, streams that interstellar bodies follow like leaves carried on rivers. The idea is not entirely new. Astronomers have already traced stellar streams, vast rivers of stars stripped from ancient galaxies and pulled into the Milky Way by tidal forces. Dark matter itself is believed to form filaments, invisible scaffolds along which both stars and gas collect. It is possible that smaller bodies, planetesimals, comets, rocky shards, might also align with such flows, drifting not randomly but in patterns we have yet to recognize. If this is true, then Atlas's arrival may not be coincidence at all. It may belong to a cluster of objects moving together, scattered across thousands of light years, their paths shaped by the slow tides of galactic dynamics. We see only one fragment, but countless others may travel the same current, invisible in the void. The sequence of Oumuamua, Borisov, and Atlas may be the first hints of these hidden structures, a whisper of rivers too vast to chart with present tools. The philosophical implications are striking. For centuries, humanity imagined itself at the mercy of random encounters. Comets strike unpredictably, meteors fall without pattern, interstellar wanderers arrive by chance. But if gravity guides them, if streams exist, then randomness gives way to structure. There is order in the chaos, a hidden logic written into the very fabric of the galaxy. And yet, such order is no comfort. If gravitational streams guide these bodies, they may deliver not just harmless fragments but catastrophic ones. Earth's history bears scars of impacts, craters carved by visitors from afar. If interstellar objects travel in unseen rivers, then one day a larger, more destructive body could arrive, guided by the same unseen hand. Order, in this sense, carries as much danger as safety. Still, the allure of hidden rivers is irresistible. It transforms the image of Atlas from a solitary exile into a participant in a grander migration. Its hyperbolic path may not be a random arc, but a thread in a larger tapestry, woven by forces too vast to perceive in a single glance. To study Atlas is to glimpse that tapestry, if only for a moment. Science has not yet proven such streams exist, but the suspicion grows. As more interstellar objects are discovered, patterns may emerge, clusters in their directions of origin, similarities in their velocities. With each new detection, the data will sharpen, and the hidden structure, if real, will become clearer. Atlas is only the third, but it may one day be recognized as part of the first evidence for a galactic current that carries worlds. For now, we are left with speculation, but speculation tinged with awe. The thought that Atlas, small and faint as it is, could be a marker of something immense, an invisible river spanning light years, channeling debris from one system to another, is a reminder of how much lies hidden in plain sight. The galaxy is not static, it flows. And within that flow, 3I Atlas may be nothing more or nothing less than a drifting leaf upon the currents of eternity. The galaxy is not still, it is a vast migration, a restless tide of stars, gas, dust, and exiles forever in motion. To place 3I Atlas within this frame is to see it not as an isolated anomaly, but as part of the Milky Way's great drift. The solar system itself is not fixed. It circles the galactic center every 225 million years, carrying Earth through different neighborhoods of space. In this ceaseless movement, encounters are inevitable. Interstellar objects are not intruders into our stillness, they are companions upon the same cosmic road. Consider the journey of Atlas. Ejected from its birthplace, it has likely crossed vast regions of the galaxy spiral, arms filled with gas clouds, regions rich in star formation, and voids nearly empty of matter. Over billions of years, gravitational nudges from stars and molecular clouds have altered its path. bending it into the hyperbolic trajectory that carried it near us. Its motion is not aimless, but the result of countless subtle pushes and pulls. To trace its orbit backward is to try to untangle the history of the Milky Way itself. The concept of galactic drift reminds us that our solar system is not immune. Just as Atlas wanders, so too does our sun scatter debris into interstellar space. Some fragments of our Oort cloud may already be drifting among the stars, unseen ambassadors of our system. In this sense, Atlas is kin to our own lost fragments, part of a cosmic trade in which no system remains isolated. The galaxy is a marketplace of matter, where collisions and ejections redistribute fragments endlessly. This exchange carries profound implications. If interstellar objects pass regularly through systems, then the galaxy is seeded continuously with material from elsewhere. Dust from Atlas may one day mingle with a newborn star's protoplanetary disk, becoming part of new worlds. Conversely, dust from distant systems may already rest on Earth's surface, carried here in meteorites too small to track. The boundaries between here and there dissolve in this drift. All worlds are linked, not only by light but by matter itself. To the human imagination, this idea is both haunting and beautiful. We are accustomed to thinking of our solar system as self-contained, its planets bound to the sun, its comets loyal in their ellipses. But galactic drift reveals a deeper truth. Permanence is illusion. Planets may endure, but fragments wander. Systems exchange their debris in a slow, silent dance that spans the arms of the galaxy. Atlas is one fragment of this dance, a participant in a migration that began before Earth was born and will continue long after our sun has faded. This vision also reshapes our understanding of rarity. To encounter 3 interstellar visitors in a decade is surprising only if we imagine ourselves separate from the galaxy's flow. Once we see ourselves as part of that drift, the encounters become inevitable. The solar system moves through the Milky Way like a ship through currents, and in those currents, countless exiles float. To see one is not chance, but consequence. And so, Atlas becomes a symbol of motion. It tells us that the galaxy is not static, that matter is not fixed, that exile and encounter are woven into the fabric of cosmic history. It is a reminder that we, too, are drifters. Earth, circling the sun, is carried along the galactic orbit, a passenger on the same migration that delivers wanderers like Atlas into our sky. Philosophically, the lesson is humbling. We are not at the center of anything, not of the solar system, not of the galaxy, not even of permanence itself. We are part of a tide that sweeps all matter along, indifferent to our presence. Atlas, in its passing, shows us a glimpse of that tide, a fragment born upon galactic drift, whispering that all things move, all things change, and nothing remains still. Speculation is the shadow cast by ignorance. When the known falters, the human mind expands outward, filling silence with possibility. For 3I Atlas, whose chemistry and behavior resist easy categorization, some have dared to wonder whether its strangeness might hint at origins even more radical than exile from another star. Could such bodies be more than interstellar wanderers? Could they be fragments of realities beyond our own, a multiverse scattered into pieces? The multiverse hypothesis is not idle fantasy. It arises from the mathematics of cosmology, from the inflationary models of the early universe. According to some interpretations, our cosmos may not be singular, but one bubble among countless others, each with its own laws of physics, each forever separate, and yet perhaps capable of leaving traces. The idea is speculative, yes, but it is not without precedent in serious theory. And in that speculative space, interstellar objects take on a new significance. What if Atlas is not only from another star system, but from another order of reality. What if its strange ratios of molecules, its irregular brightness, are not quirks of distance, but reflections of physics tuned slightly differently, chemistry written in a dialect foreign even to our galaxy? The thought unsettles, because it stretches beyond what data can confirm, yet its allure lies precisely in that stretching, in testing the limits of imagination against the unknown. In some models of cosmic inflation, bubbles of universes form, collide, and leave imprints. Most of these universes would forever remain beyond our reach, but collisions between them might scatter fragments. Matter forged under slightly different conditions could, in theory, wander into our cosmos. Such fragments would appear anomalous, inexplicable within our framework, behaving in ways that strain the categories of comet and asteroid. Could Atlas, faint and uncooperative, be one such fragment? Mainstream science, cautious and grounded, resists such leaps. It seeks explanations in turbulence, in gravitational scattering, in familiar forces stretched to their limits. And yet, the history of science is one of boundaries broken. Dark matter, once unthinkable, is now a central pillar of cosmology. The expanding universe was once ridiculed until Hubble's data made it undeniable. The multiverse, for now, remains speculative, but to link it with anomalies like Atlas is to give imagination a foothold in the real. Philosophically, the idea carries weight. If Atlas were such a fragment, it would not only be alien in origin, but alien in essence. To touch it, even in thought, would be to touch the beyond. It would mean that our universe is not a sealed system, but a porous one, through which traces of other realities may drift. In that vision, Atlas is not only a messenger from another star, but from another existence altogether. The beauty of such speculation lies not in its likelihood, but in its perspective. It reminds us that the cosmos is stranger than we assume, that the anomalies of faint objects may carry implications far beyond their size. A shard of ice and rock, tumbling silently through the void, becomes the stage upon which humanity projects its deepest questions. Are we confined to one universe, or are we part of something infinitely larger? Is the matter we know all that exists, or is it only one variation among endless forms? Atlas itself offers no answer. It drifts in silence, its faint spectrum insufficient to confirm or deny such wild conjectures. But its refusal to conform its silence, its ambiguity creates a space where imagination and theory intertwine. And in that space, Atlas becomes more than an interstellar object. It becomes a mirror, reflecting back not only starlight, but the restless human longing to break beyond the boundaries of the known. Time is the most elusive dimension of all. Space can be measured, mapped, traversed in thought, but time resists such mastery. It flows in one direction, carrying all things toward decay, yet physics whispers of its malleability slowed by gravity, stretched by velocity, even rewound in the equations of quantum mechanics. When 3I Atlas entered our system, some could not resist, wondering whether its strangeness was not only spatial but temporal. Was it truly just from afar, or could it also be from another epoch? To entertain this thought, one must consider what exile across billions of years truly means. If Atlas was ejected from its birthplace soon after its star ignited, it may have been drifting for as long as our sun has existed. In that case, it is not only from another place but from another time older than Earth, older than oceans, older than life itself. Its atoms have carried their silence through eras when our planet was molten, when continents had yet to form, when no living thing had drawn breath. In encountering it, we are not just seeing across distance, but across history. Time complicates the chemistry it carries. Cosmic rays, striking its surface for millions of years, may have altered or erased volatile compounds. Its brightness, its shape, its very fragility may be scars of temporal endurance. The body we observe may be less a pristine relic than a weathered survivor, its original story buried beneath layers of radiation damage and micrometeorite scars. In that sense, Atlas is a palimpsest, a manuscript written by time, overwritten again and again until its first words are almost illegible. But some thinkers, gazing at its anomalies, take the thought further. What if Atlas is not merely old, but displaced? What if the strange trajectory and faint irregularities hint at physics that bend time as well as space? Einstein showed that motion near light speed alters time's flow, that gravity slows clocks, that the universe itself stretches time in its expansion. Could such principles, applied on cosmic scales, send fragments not only across space but across epochs? Could Atlas be not just an exile from a distant system, but a messenger from an earlier moment in the galaxy's own story? These are speculative questions, but they resonate with a deeper truth. Every interstellar object is a time traveler. Whether displaced by physics or simply by endurance, it carries with it an age alien to us. In touching its light, we touch an object that has drifted since before humans evolved, since before Earth cooled, since before our sun was even old enough to be stable. Atlas is therefore not only a spatial stranger, but a temporal one, an emissary from a chapter of history too vast for our imaginations to fully grasp. The philosophical weight of this is immense. To study Atlas is to confront the brevity of human existence. Our civilizations rise and fall in centuries, our species in millennia, yet this fragment has wandered for billions of years, indifferent to our presence. It reminds us that time is not measured in human terms, but in cosmic epochs. We are temporary listeners to a story that began long before us and will continue long after. And yet, there is solace in this thought, for if Atlas has endured so long, if fragments can survive ejection, drift, and endless radiation, then endurance itself is possible. Matter remembers. Even when worlds are destroyed, when systems collapse, fragments remain. They wander, they persist, they outlast. Atlas is proof that memory exists in material, that nothing in the cosmos is ever fully lost. Thus, when we watch Atlas fade into the dark, we are not merely watching a rock pass by. We are watching time itself, embodied in matter, move through our system, a messenger from another epoch, brushing against the present, whispering that all moments are connected by endurance, and that time's true scale is written not in years but in billions. For decades, humanity has searched the skies for signals, for a voice among the stars. The effort has been vast. Radio telescopes sweeping the heavens, optical instruments straining for flashes of artificial light, computers analyzing torrents of data for patterns beyond randomness. This collective endeavor, SETI, the search for extraterrestrial intelligence, has so far returned only silence. No transmissions, no unmistakable technosignatures. Yet when interstellar objects like 3I Atlas pass through our system, the silence takes on a sharper edge, for what could be a clearer opportunity than a messenger from beyond? If civilizations exist elsewhere, they may scatter artifacts rather than signals. Radio waves fade, light pulses are swallowed by dust, but objects, material fragments can endure. A probe released into the galaxy could travel for millions of years, carrying its maker's intentions long after their voices are gone. Some theorists argue that interstellar wanderers might be the most natural technosignature of all, not beacons broadcasting deliberately, but relics drifting silently, awaiting discovery. With this in mind, every new interstellar object ignites speculation. Oumuamua's strange acceleration stirred whispers of a solar sail, a relic craft propelled by starlight. Borisov, with its cometary tail, seemed purely natural, yet even its exotic chemistry was passed for hints of intention. Atlas, quiet and ambiguous, enters the same arena. Could its faint flickering, its irregular form, its silence of volatiles be the remnants of something constructed, long since broken, long since abandoned? SETI scientists tread carefully here. They know how tempting it is to project hopes onto anomalies, how easily mystery becomes a mirror of human longing. Most insist that Atlas, like its predecessors, is best explained by natural processes: ejection, fragmentation, erosion by cosmic rays. Yet the possibility, however slim, remains. And in that possibility lies meaning. For what if the silence of SETI is not the silence of absence, but the silence of the wrong search? What if civilizations do not broadcast, but scatter? What if their legacy is not light or radio, but objects millions of fragments, some intact, some broken, moving quietly through interstellar space? In that case, visitors like Atlas are not accidents, but opportunities. They may carry no signals now, but their very presence testifies to the galaxy's restless exchange of matter. And in that exchange, intention might hide. The thought is haunting. Civilizations may die, but their artifacts endure. If Atlas were such an artifact, damaged, eroded, unrecognizable, it would be a grave marker, drifting endlessly, the silence of SETI embodied in stone and ice. It would not speak, but it would remind us that others had once existed, that silence is not emptiness but aftermath. Philosophically, this transforms SETI from a search for voices into a search for relics. Instead of waiting for signals, we might learn to study visitors like Atlas with forensic care, searching for anomalies that cannot be explained by nature alone. Perhaps one day, in the dust of a passing fragment, we will find alloys unknown to nature, geometries too precise to be chance, molecules too deliberate to be random. Until then, we listen, we watch, we wonder. Atlas gave no such revelation. Its silence matched the silence of the cosmos at large. No signals emanated, no alien fingerprints revealed themselves. And yet, its passing rekindled the urgency of the search. For even silence carries meaning. Silence tells us that the galaxy is not eager to reveal itself, that if life is out there, it does not shout, it whispers, or perhaps says nothing at all. And so, SETI listens still, with ears both literal and metaphorical. Atlas passes into the void, leaving no proof, no message, no voice. But in its wake remains a question as vast as the stars. Is the silence of the universe the silence of absence, or the silence of waiting? Some mysteries pass too quickly for us to follow. 3I. Atlas was one such mystery, a brief flare of otherness against the familiar sky. By the time telescopes turned their full gaze upon it, the visitor was already retreating, its light weakening with every night. There was no spacecraft poised to chase, no mission ready to intercept. It came and went as silently as a breath, leaving us with only the traces we could gather before it vanished. This limitation is not new. Oumuamua slipped through our grasp in the same way, noticed too late for pursuit. Borisov, though brighter, also fled beyond our reach. In every case, humanity's instruments were confined to Earth and its orbit, straining to capture what scraps of data they could before the chance was gone. The frustration is immense. For here are fragments from beyond the solar system, carrying within them the stories of alien stars, and yet we cannot touch them, cannot sample them, cannot keep them close. They arrive as gifts, but vanish before we can unwrap them. The reality is sobering. Our technology is not yet fast enough. To chase an interstellar object requires velocities far beyond those of present spacecraft. Even our most ambitious missions, Voyager, New Horizons, crawl compared to the hyperbolic flight of these wanderers. By the time an intercept mission could be launched, the visitor would already be gone. To truly study them, we must anticipate, prepare, and wait with engines ready. But Atlas offered no such luxury. It appeared faint and fleeting and left before we could act. For the scientists who watched it fade, there was a quiet grief, not grief in the human sense, but the sorrow of opportunity lost. They knew Atlas carried secrets, its composition, its structure, its scars from ejection, and yet those secrets are now sealed forever in the silence of distance. To watch it go was to feel the limits of our reach, the smallness of our grasp against the vastness of cosmic drift. And yet, even in this loss, there is meaning. The inability to follow Atlas reminds us of our place in the story of exploration. We are at the beginning. Our telescopes are sentinels, our spacecraft scouts, but we are not yet hunters of interstellar mysteries. We can glimpse, we can wonder, but we cannot yet pursue. The frustration itself becomes a catalyst, a spark that will drive the building of faster craft, the designing of missions that wait in readiness for the next arrival. Already, space agencies and theorists imagine interceptor probes that could launch quickly, accelerating with solar sails or nuclear propulsion to meet the next wanderer. For Atlas, the chance is gone. It fades into the outer dark, carrying its truth with it. We will never know its full story. But in that absence lies a lesson as profound as any data could give. The universe does not wait for us. Its mysteries pass whether we are ready or not. Our task is to be prepared to anticipate, to act swiftly, to meet the next messenger with hands outstretched instead of eyes only. Philosophically, there is humility in letting go. To accept that Atlas will never yield its full truth is to confront the limits of science, the boundaries of time and technology. Yet, there is also beauty in the glimpse itself, for even if we cannot follow, the very fact of its passage enriches us. It reminds us that we are not alone in matter, that our solar system is part of a greater flow. We may not hold Atlas, but it has touched us nonetheless, brushing our awareness with the vastness of the galaxy. So Atlas departs, carrying silence, carrying mystery, carrying a story we will never fully read. We cannot follow, but we can remember. And in remembering, we prepare for the next arrival, the next fleeting gift from beyond, the next moment when the galaxy reveals a fragment of itself before turning away once more. There is a strange philosophy in glimpses. Humanity often learns not from what it possesses, but from what it cannot keep. A falling star streaks for seconds before vanishing. A comet blazes briefly before fading into black. An interstellar object like 3I Atlas appears once, never to return. The cosmos seems to whisper that our role is not to hold but to witness, to gather meaning from the transient. Atlas is the embodiment of this truth. No spacecraft will ever touch it. No probe will bring back its dust. Its secrets are not ours to own. Instead, we are left with fragments of observation, incomplete measurements, and speculation. This incompleteness is not failure, it is the condition of existence. In glimpses, we see enough to be changed, even if we never know the whole. Astronomy has always been built on fragments. Ancient stargazers had only naked eyes, charting patterns in the sky without understanding their true nature. Galileo glimpsed the moons of Jupiter through a crude tube of glass, not knowing the full mechanics of orbital resonance. Hubble glimpsed the faint smudges of galaxies, proving the universe's expansion, but leaving dark energy a mystery. Each glimpse is partial, yet each carries power. From pieces, we build frameworks. From fragments, we construct truths. Atlas teaches us again that glimpses are the way of knowledge. Its faint flickers told us of irregular shape. Its shallow spectrum hinted at alien chemistry. Its hyperbolic path proved its exile. These are not complete answers. but they are glimpses enough to remind us of the galaxy's vast exchanges, enough to change our perspective, even without final clarity. Philosophically, the fleetingness of Atlas mirrors human existence itself. Our lives, too, are brief passages through a vast cosmos. We glimpse meaning, love, truth, but never hold them completely. We gather fragments, incomplete but transformative. Just as Atlas brushed the solar system before vanishing, so do our own lives brush against eternity, leaving traces but never permanence. There is also humility in this philosophy. The universe does not perform for us. It does not tailor its mysteries to our readiness. We are given glimpses because that is all we can handle for now. In those glimpses lies both frustration and beauty. Frustration that the whole remains hidden, beauty that even a fragment can reshape our imagination. The lesson of Atlas, then, is patience. It tells us that science is not the art of instant answers, but of building meaning from glimpses, awaiting the next fragment, layering them into coherence across generations. It is the recognition that wonder does not require possession, that to see, even briefly, is to be transformed. And so Atlas becomes a parable, not an object defined by what it gave, but by what it withheld. A glimpse of an alien system, a fragment of a hidden history, a whisper of truths too distant for now. We cannot keep it, cannot follow it, cannot know it fully, but we have seen it, and in that glimpse lies all the power we need. In every mystery the cosmos gives us, there is a reflection of ourselves. When 3i Atlas crossed our skies, faint and fleeting, it carried not only questions about other systems but mirrors of our own condition. For what is an interstellar exile if not an echo of mortality? A fragment born, cast adrift, destined to pass briefly through light before vanishing into darkness again. In Atlas's journey, we see our own. Human life, measured against cosmic time, is a flicker, a few decades in the scale of billions of years, a heartbeat in the life of stars. We, too, are transient visitors, brief phenomena shaped by forces larger than ourselves. Like Atlas, we are ejected from beginnings we barely comprehend, born into existence without consent, set on trajectories we cannot fully control, drifting toward an end we cannot escape. This recognition is not despair, but revelation. The fleetingness of life does not diminish its meaning, it sharpens it. Just as astronomers cherish every photon of Atlas before it fades, we learn to cherish every moment of our own passing lives. The fragility of existence is the very thing that makes it luminous. A fragment from another system, shining briefly in our sky, is precious because it will never return. So, too, are our days, our loves, our questions. The analogy deepens when we consider the scars Atlas likely carries erosion from cosmic rays, fractures from collisions, irregularities that betray a violent past. Human lives, too, are shaped by impacts and storms. We are fractured, scarred, irregular, yet we endure. Our beauty lies not in perfection, but in survival, in the persistence of light despite the inevitability of fading. There is also the reminder of connectedness. Atlas does not travel alone in spirit. It is one of countless wanderers, just as we are one of countless lives across Earth. The solitude of mortality is softened by the realization that all beings share the same passage: birth, drift, departure. Just as interstellar bodies populate the galaxy in numbers beyond counting, so do moments of existence populate the story of humanity. We are each exiles, but exiles together. In reflecting on mortality through Atlas, one also sees continuity. Though Atlas departs, its atoms remain. It will drift for billions of years more through regions of the galaxy we will never see. It may one day strike another system, merging with its dust, contributing to new worlds. In this sense, Atlas is never truly lost. Its form changes, but its essence persists. So, too, with us. Though lives are finite, the matter that composes us endures, becoming part of new forms, new stories, new journeys. Mortality is real, but so is transformation. Thus, Atlas becomes not only a scientific curiosity, but a philosophical mirror. Its fleeting passage reminds us that existence is fragile, transient, and yet profoundly meaningful. To vanish is not failure. To pass is not emptiness. The very brevity of our lives, like the brevity of Atlas's visit, gives urgency to wonder, intensity to love, weight to memory. In watching Atlas depart, we are reminded of our own departure, and in that reflection lies both humility and hope. For though we are transient, we are also luminous for a time. We leave traces in those who see us, in the world we touch, in the universe that remembers us in fragments of dust and light. Knowledge has horizons. No matter how far telescopes peer, no matter how precise equations become, there are always edges, boundaries where clarity dissolves into mystery. The passing of 3I Atlas is one such horizon. We learned fragments of its story, its trajectory, its irregular brightness, its faint hints of chemistry. But its essence remains unresolved, slipping into the dark before we could capture it fully. And yet, the very limits of this knowledge illuminate the future, showing us where we must look, what we must build, and how we must imagine. The first horizon is technological. Atlas revealed how unprepared we are to pursue interstellar wanderers. By the time they are detected, they are already receding, too fast for any spacecraft we now possess to chase. The horizon of knowledge, therefore, demands new tools. Engineers dream of interceptors kept in readiness, probes that could launch at short notice to meet such objects. Concepts of solar sails, nuclear propulsion, even gravitational slingshots are being studied with urgency. The mystery of Atlas reminds us that the next visitor may not wait, and preparation must begin now. The second horizon is observational. Wide-field surveys like Pan-STARRS and the forthcoming Vera C. Rubin Observatory expand our vision, catching transient bodies with greater sensitivity than ever before. Where once only the brightest comets were seen, soon we may detect thousands of interstellar exiles. Each will expand the sample, each will add data points to refine the statistics of galactic debris. Atlas may have been elusive, but it sharpened the hunger to see more, to fill the silence with a chorus of new discoveries. The third horizon is theoretical. Interstellar objects challenge our categories. They blur the line between comet and asteroid, natural and possibly artificial, familiar and strange. To make sense of them, science must expand its frameworks, embracing uncertainty, welcoming ambiguity. Models of planetary formation must account for the vast numbers of exiles, for the galactic rivers of debris, for the strange chemistries that do not conform to our expectations. Atlas is a puzzle piece that forces the reshaping of the puzzle itself. And beyond these horizons lies the philosophical. The mystery of Atlas is not only about data, but about meaning. It asks us what it means to be part of a galaxy in motion, to live in a cosmos where matter migrates endlessly, where fragments from alien systems pass through our skies unnoticed until chance brings them into view. It challenges our illusion of isolation, reminding us that no system, no planet, no star is sealed. The universe is porous, restless, connected. In contemplating these horizons, we recognize the paradox of science. The closer we look, the more we realize how much remains unseen. Atlas is not a disappointment because it left us with questions. It is a success because it revealed horizons we had not yet imagined. It is not failure to admit ignorance, it is progress to glimpse where the edges of knowledge now lie. And so, The horizon of knowledge is not an end but an invitation. Atlas may be gone, but its passing points the way forward. New telescopes, new missions, new theories, each will rise from the silence it left behind. In its brief arc across the solar system, Atlas has become a guidepost, showing us where the boundaries are and where we must cross next. The darkness reclaims what it lends. 3I, Atlas, faint and stubbornly enigmatic, has already receded beyond the range of our instruments. Its light weakens into invisibility. Its trajectory carries it back into the cold gulf between the stars, and with it, the answers we longed for remain sealed. There will be no return. The third interstellar visitor fades like a dream at dawn, leaving only traces in memory and data. Departure is always quieter than arrival. At first there was excitement, emails rushing between observatories, telescopes racing to capture every photon, theories rising to meet anomalies. But as the weeks passed, the object dimmed. Instruments recorded less and less, until at last there was nothing left to see. The silence that followed was not abrupt, but gradual, like a voice whispering further and further away, until the words are no longer discernible. Atlas left as it came, in silence, in mystery, in passing. For astronomers, the departure is bittersweet. They hold what data they could gather, knowing it is incomplete, yet knowing too that it is enough to matter. Its orbit is recorded, its light curves stored, its spectra preserved. From these fragments, generations may continue to debate, to model, to speculate. Atlas is not gone entirely. It survives as numbers, as memory, as a symbol of the porous galaxy in which we live. But the body itself, the tangible fragment of another world, is lost to us, continuing on its lonely flight toward the infinite. And here the story folds into philosophy. Atlas's departure reminds us that the universe does not bend to human desire. We cannot demand permanence where only glimpses are given. We cannot command the cosmos to linger, so we may study it fully. Our task is to notice, to listen, to take meaning from the fleeting. The galaxy offers fragments, not wholes. To cherish them is to accept our role, not masters of the universe, but witnesses to its wonders. In this acceptance lies a profound reflection on humanity itself. We too are transients. Like Atlas, we arrive briefly, drift across the stage of existence, and fade into the dark. We carry mysteries within us, fragments of ancestry and memory, scars of survival and loss. And, like Atlas, we leave traces, our light reflected in others, our atoms scattered, our stories written in the memories of those who glimpsed us before we passed. As Atlas recedes, what remains is wonder. Wonder that such a fragment found its way here. Wonder that humanity was ready, with eyes sharp enough, to notice. Wonder that across the immensity of time and space, something so small could carry such weight. The quiet departure is not emptiness, it is fulfillment. It reminds us that beauty often lies not in permanence, but in passing. And so, the last glimpse of Atlas dissolves into night. It becomes again what it always was, a wanderer without audience, a fragment of a distant world continuing its endless flight. For us, it leaves only silence and memory. But within that silence, something massive has been revealed, not in answers, but in the questions that linger, echoing long after the light has gone. The story slows now. The voices of telescopes grow still, their domes turn to other skies, their sensors quiet in the night. 3I Atlas has passed, and with it, the urgency of pursuit fades into a softer reflection. What remains is not noise, not certainty, but a calm after wonder, an awareness that we have brushed against the infinite and survived the encounter with awe intact. Imagine the fragment now, drifting deeper into coldness, its surface untouched by sunlight, its path unbent by gravity's grasp. It is invisible, but not gone. It carries onward, a solitary pilgrim of eternity, its journey endless, its silence absolute. We cannot follow, we can only imagine. Yet in imagination lies a kind of closeness, a thread that binds our fleeting lives to its endless exile. For in truth, we too are wanderers. Earth drifts through space, the solar system circles the galactic core, our species traces its fragile arc across the brief canvas of history. Like Atlas, we move through light and darkness, appearing for a moment before vanishing again. The recognition is not despair, it is peace. To know that all things drift is to know that we are part of a larger rhythm, one written into the structure of the cosmos itself. And so the narrative closes, not with noise, but with stillness, with the assurance that mystery endures, that wonder is inexhaustible, that silence is not emptiness, but invitation. 3i Atlas has gone, but its passing has left a trace upon us. We are changed, made larger by the questions it raised, gentler by the humility it inspired, steadier by the calm it leaves behind. The stars remain, the wanderers will come again. Until then, we wait in quiet reverence. Sweet dreams.